Hi guys, how are you today? So today I'm going to talk about the movement of the earth and seasons. And the reason why I want to include it on this particular lesson is because it is really about the center of the earth, okay? Here are standards for fifth grade that we have to learn. And of course, let me turn off that light. Everywhere I find there's too much light in my house, and I can't find a good place to record. I apologize. I have a lot of windows, so there's always going to be light somewhere. But there are two significant movements that made by Earth. The first movement is the Earth rotation on its own axis. So it rotates like on itself, okay? It takes the Earth about 24 hours to complete that rotation. And the second significant movement is Earth's revolution around the sun, okay? One revolution takes 1 full year, 365 and a quarter days. The movements made by Earth determine changes in weather, ecology, and in the number of daylight hours that we get, okay? Earth rotation. Now let's talk about Earth rotation night and day when it goes around its own axis. The sun is an average size, right here, star that lies in the center of the solar system for providing heat and light energy to Earth and the other planets in the solar system. The Earth is the third planet from the sun, and even then it is about 150 million kilometers away. So you can imagine how powerful the energy from the sun is. Then even at that great distance, we still can have life on Earth. Earth rotates from west to east on an imaginary line called axis. The axis passes through the center of the Earth from the North Pole, okay, to the South Pole. It takes 24 hours or 1 full day and night for the Earth to make one complete rotation around itself. At any given time of day, half of the Earth faces the sun and the opposite half faces away from the sun. So this is for something else, but you would see that sometimes it'll be facing the sun like that. And then sometimes, because it's going around itself, that black part that I drew here, it's going to be facing the sun, okay? That's going to be night. So the half of the Earth closest to the sun experiences daytime, while the half of Earth, in this case, is experience nighttime. Actually, which one's closest? I didn't put one example like that. It's okay. It is Earth's rotation that then causes day and night. Now we have what we call Earth revolution, and those are your seasons. Earth and everything else in our solar system revolves around the centrally located sun, goes around it. Due to the sun's strong gravitational pull, wow, it must be like huge, that pull. Earth takes 1 full year, 364 and 1 quarter days to make a complete trip or revolution around the sun. The seasons are caused by the tilt of the Earth on its axis, and it revolves around the sun. Earth does not sit straight up, but it is tilted 23 and 1/2 of a degree on its axis. That's why you see here that I don't make that line straight, because there is a tilt there. Earth moves counterclockwise in an ellipse-shaped pattern around the sun. Okay? So instead of going this way, it goes this way. This tilt affects the amount of sunlight different areas of Earth receive at different times during the year, causing the 4 seasons, which are winter, spring, summer, and fall. When the northern hemisphere is tilted towards the sun, it is summer there, but winter in the southern hemisphere. So that would happen right now. We're in spring, going on to summer pretty soon, in a month and a half. So that means that in the southern hemisphere, in Argentina In Australia, it's going to be the opposite. They're going to be heading into winter. Well, we're just coming out of winter. Seasons in the southern hemisphere are opposite those in the northern hemisphere. And just so you know, here's your Earth. Southern hemisphere is going to be everything down below. Northern, which is where we are, North America, we're at the top of the Earth part. Okay, so we belong to the north. Even though we are down south in South Florida, we're still on the northern hemisphere. Okay? Okay, but if you're from Argentina or from one of those countries in the southern hemisphere, you know that it's just kind of like the opposite. Now we have stars in the sky, and there are two key motions affecting the objects seen in the night sky. The first of these motions, again, is the rotation of the Earth on its own axis. This motion causes the star to have the appearance of moving across the sky, but it is not the stars that are moving, it's the Earth. The second motion involves the revolution of the Earth around the Sun. Earth's orbit around the Sun is responsible for the varying parts of the sky that are seen during the different seasons. As the Earth rotates from west to east on its own axis, the stars will appear to move in the opposite direction. And I just put some pictures here. In this picture, it looks like the stars are over here on this side, here over here, here over here, here. Okay? The stars rise in the east and set in the west as a result of Earth rotation. The North Star, which is right here, which is called Polaris, lies almost directly above the Earth's rotational axis. Polaris, almost above of it, okay? And it appears to remain motionless in the sky. All of the stars appear to rotate around the North Star. The star appears to be moving in different points, but the cause is actually the rotation of the Earth. Now, one last thing, Earth revolution causes visual variations of parts of the sky. As the Earth revolves, different groups of stars may be seen at different times of the year. The Sun blocks groups of stars for up to 6 months at a time. The visibility of stars is solely dependent upon the latitude of the position on Earth as it revolves around the Sun. Okay? And then tomorrow we'll just do a little more review on this. All right, guys? Have fun. See you tomorrow.